how to access all the ObjectiveC APIs using JSI. I've come here in the middle of a typhoon to deliver this elaborate bridge metaphor, so I hope it was worth it. Enjoy the show.
For the contents, first off we'll be introducing myself, then we'll go into the background of what we're trying to solve here, of native API access being annoying. We'll move on to how to use JSI because it's not documented at the moment, and then we'll get into the ObjectiveC runtime access. We'll start with a simple serializable API access and then move on to arbitrary non-serializable APIs. Finally, we'll just wrap up. Now, who's talking? I'm Jamie Birch. I work with all platforms. I work with the web at Birch. I work on React Native when I'm making Lingo Browse, and I'm on the NativeScript Technical Steering Committee, which exposes me to various ideas, different ideas about how to handle JS to native communication. Lastly, and above all, I'm an enemy of native code. So, background. Accessing native APIs is a pain. It's boilerplate city. It may involve installing, possibly forking an NPM module. It requires rebuilding, and that might be an Xcode rebuild, not a JS bundle rebuild, your app. And all of this is about breaking your workflow, switching your context, and it's just painful. So how could it be better? What if you could call all native APIs directly from JS? Suppose you had a function call phone number. It takes in a phone number as a string, and from there it starts calling native APIs. We use NSURL, we call a class method on it, we look into UI application, get a class property, call an instance method on it, and as our final party trick, you'll notice when we're passing that closure into the function, it's going to be automatically marshaled just like all the other ObjectiveC objects from JavaScript into native, and I think that's just magical. Magical, yes, but it's not like it's never been done before. It's been done by NativeScript, Hyperloop, Dynamic Cocoa, JS Patch, and even Xamarin. Although Xamarin is the same thing for C# rather than JavaScript. Why should we care? The idea would be that if you can access all native APIs through JavaScript, maybe you never ever have to write a native module ever again. You never have to touch Xcode. You just need to know what SDKs are available. And other library developers can use this concept of direct native access through JS, and they can start making native libraries using JS, which is nice. It's ergonomic. It's what we're used to. Why we came to React Native. So how would we go about this though? We'll need something that's synchronous, fast, and supports native data types. Doesn't sound like the old classic JSON bridge. Sounds like a job for JSI. So let's set up an app that uses JSI, get everyone on the same page. It all starts the same way you make a regular app. We all start a standard React Native project from the TypeScript template. We'll open up the Xcode workspace and we'll run the target scheme. If this much, the Hello World app fails to run, you will need to fix your environment. Now, we'll start making some files, put them alongside your app delegate, and just give them these names, ObjectiveC runtime, and we'll fill them in the following slides. Here's how you add the files to the Xcode project instantly. Now, let's set up our JSI module. The JSI module, the actual installation, the bootstrapping can, if maybe it's different for turbo modules. I don't really know the deal with those, but certainly the way I do it is you actually start a classic JSON bridge style module. So here we're importing RCT bridge module and we're extending that class. Nothing special going on here. Here's the implementation for it. It will all look pretty familiar if you've made a classic bridge module before. So we implement this class, ObjectiveC runtime. We export it with the same name, so that's no params going into that macro. And we ask to be set up on the main queue because we may be accessing UI thread later on. We've got the installation lifecycle and the cleanup lifecycle. We'll be using those in a moment. So while we're here, we might as well get a reference to the bridge. So we'll just synthesize a setter for the bridge named mbridge. That M stands for member, incidentally. And so during the installation lifecycle, we will just grab a reference to that bridge. And this allows us to clean up later in the invalidate lifecycle. Next up, we want to grab the JSI runtime. So we'll import the JSI headers, and we'll start using the namespace Facebook. This might be the first bit of C++ that we're seeing so far. And what this does is it shortens your imports from Facebook JSI runtime to just JSI runtime. So the next thing we do is we grab that bridge reference and we cast it to RCT CXX bridge, which has a runtime property which we can grab. If that turns out to be null, we bail out and yeah, we're kind of end of the road there. Now, what we're going to try doing here is set an object in the JavaScript context. So forget the native side for a moment. Imagine you're writing some JavaScript and you write global.objc, or can I just say ObjectiveC? Now, we'd like when you console log that for it to return a string, and that's what we're going to set up here. So the way we approach that, point number 1 in the comments, we'll create a JSI string from a C string. So we've got this factory method from the JSI library, which goes JSI string, create from ASCII. We pass in the runtime, and you'll see that star there means we're dereferencing the pointer to it. I don't know the details, that's just what it wants. And the second thing we're going to do is we're going to pass in a C string. Note how, unlike an Objective-C, there's no @ symbol at the start of it. So it's a real C string, it's not an NS string. So we've created our JSI string, we've got it in hand, and we're just going to call this method here, which is runtime global set property. You notice that little arrow there after runtime? That's dereferencing runtime and grabbing a member variable from it. Or we're invoking it. Anyway, it's a thing. It's a thing on the instance. And again, we dereference a runtime pointer. We say ObjC is the name of the thing we want to set, the property we want to set on the global object, and then we pass in that JSI string as a value. Lastly, don't forget cleanup. It's just good habits. Cleanup gets called, invalidate rather, gets called on full refresh, for example. So we want to make sure that anything we did up until now gets cleaned away. We grab a reference to the JSI runtime as we did before, and the way we'll approach this is we'll just do the opposite of when we set property ObjectiveC to a value. This time we'll ask for an undefined value, because you can't actually delete, but you can overwrite rather. If you had any native objects or anything here that you needed to clean up, now would be the time to do it, but so far we don't. Final part, we'll go into app.tsx and we'll try and call this thing that we've just set up. So point number 1, we'll declare a constant named ObjectiveC. It's going to be any type. It's actually string type technically, but later on we will need it to be any, so let's just have it as any from now. Now, point number 2, we'll set up a use effect that will run upon mount and dismount, and we'll just log out ObjectiveC. Hopefully, at this point, you'll see in the console the text ObjectiveC, a C string. If not, you may have run into a startup race condition. Now, this is one of the infuriating parts of first getting involved with JSI. If you've created a module just the way I have, there's a large chance that the first time you build, it won't have installed your JSI module by the time you use it, even if you do a set timeout to wait. I don't totally understand why, but there is a workaround. Here's where to find it. You go into Modulo's React Native Quick Crypto, and you just search for RCT export blocking synchronous method. And what they've done is they've made an approach where you install the module explicitly and block the runtime in order to do that. And this allows lazy loading, whereas here we're relying on eager loading happening at the right time, which clearly it sometimes doesn't. Now, that was a string, but JSI supports a lot more than strings, so how do we do that? Now, the way I'd like to present this is with a cheat sheet, which you can take home for your own reference. So there's strings, there's numbers, there's booleans, and a lot more. Let's go into strings first. The JSI string, I should probably clarify for those who haven't seen any C++ before, JSI, I'm pretty sure that's a namespace. String, I think, is a class. These colons just mean go down into the next layer, And then on that class, we're going to call a class method. Other languages call it a static method. I don't know what C++ actually wants us to say, but anyway. So we have this create from ASCII and create from UTF-8, and that's because it's expecting a C string to be passed in, but it wants you to tell it what encoding format you're imagining this string to be. So the easiest way to write it is a C string, like the least number of things to type, but a lot of the time you'll be holding on to an NS string. So if you have an NS string, you can ask for the UTF-8 string property, which will give you a C string in UTF-8 representation. Now, move on to numbers. We have this JSI value class, which has an overloaded constructor, and based on what you pass in, it will figure out what you probably want. If you pass in a C number, it'll interpret it as a double, because all JSI numbers are doubles. Equally, you can pass in an NS number, but pull out the double value from it. And that's the longhand way of writing NS number. You could use the LLVM shorthand to write an NS number as well, with the @ symbol in front of the C number. Booleans are quite funny in Objective-C. You've got all sorts of ways to write booleans, like true and yes. Now, the only ones that work are the ones that are based on characters. So this capital true or capital yes. All the other ones don't. We've got null. You could pass in a null pointer to the value constructor, or you could use the null convenience method. Undefined convenience method. Object, you use the object class instead, and you pass in a pointer to a runtime and dereference that. Host object, a bit more complicated. You ask for create from host object method. You pass in the runtime pointer, dereference it, and then finally, this looks a bit alien, but we're going to create a instance of a host object and wrap it with a shared pointer. And yes, it's alien, and we'll come back to it later. Also, make shared, shared pointers might not be the only way to go about this, but one way will do, right? It's memory management in C++ is a big topic. Part 3, there's big ints. I'm not going to say too much about them. They've just been merged into master, and they're not supported by the JSC runtime yet, for example. Symbol, I think you can only clone them out of the JS context. I don't think you can create them afresh. Functions. Functions are the lifeblood of JSI. Gives you so much power. A little bit complicated, very scary if you're just coming into C++. So what we're looking at here is a host function followed by the actual creation of JSI function. So let's zoom in on the host function first. That word auto there means please infer the type for me. We're going to be making a function that sums two numbers together. That opening sort of square bracket thing, that's the dependency list of things you want to pull into this closure. And in this case, we've got no dependency we want to pull in, so we'll leave that empty. This closure accepts 4 arguments. It has a runtime, it has this value in case you want to access this outside the closure, or inside the closure rather. And then it's got the start of the arguments list and the number of arguments present in that list. And you'll see the arguments are each just a JSI value, but you need to, for each one, express which type you want it to be expressed as. And depending on whether you call getNumber or asNumber, you can implicitly get a checking of the type, an assertion, as you're about to do that. And so now we've made our host function, and we just need to make the JSI function. You'll see JSI function create from host function, pass in and dereference via the runtime pointer, provide a prop name for it, which is pretty simple. We're going to call our function sum on the JavaScript side. So we say sum, please. We tell it it's got 2 arguments, and we give it the host function. So now you know all the kind of types we can make, the primitive types in JSI. It would be handy to not have to write all the boilerplate for it each time. And so what I found very helpful is this JSI utils file that Mark Ruzavi makes use of in his React Native Vision Camera library. I believe it was originally extracted from RCT Turbo module. So maybe one day it will actually become something you can import straight out of React Native Core. And it provides a bunch of functions like convert NS string to JSI string and convert JSI string to NS string, which saves you a lot of reinventing the wheel on your side. So now you're fluent in JSI, let's start building our ObjectiveC runtime projection. We're going to get into lots of ObjectiveC method programming, and the point is maybe less for you to be able to walk away from this writing your own ObjectiveC runtime, but more just knowing what the possibilities are and seeing a few ways that we can make use of JSI. So let's set out the objectives, what we're aiming for right now. We're going to create a host object via JSI that can be accessed globally from JS as ObjC. So if you write global.objc, in your JS code, it will give you a host object on the JS side. That host object will, before we populated it, it's just going to look like a regular JavaScript object, but after we've actually filled it all in, it will provide an experience similar to writing ObjectiveC. You'll be able to access constants, classes, method calls, and when you pass JavaScript data types into it, whether it's a JavaScript string or actually another host object you had from some other function call, it will be marshaled as it's coming through to the native side, and it'll unwrap relevant parts of it and say, oh, I see there's a string under there, I know what to do with that, for example. And for this talk, we'll implement getters. I'm afraid I don't have time to cover setters, but it's really much the same thing, just you're calling different ObjectiveC meta programming functions. So yeah, we'll just do getters for now. So first off, our global.objectivec value is returning a string. Let's make it return a subclass of JSI host object instead. So to start off on this, let's make a couple of files, host object, ObjectiveC, and they'll be empty for now. Add them to a project. And here's where we start really seeing some JSI. Here's the interface. We're going to import the JSI headers, and we're going to use namespace Facebook to shorten our imports. We've got a class with a macro, I think that might be, I don't really know, JSI export. Our class named host object, ObjectiveC, is extending a JSI host object. And so it's going to override a couple of host objects APIs. It's got the get API and the get property names. And on the next slide, I'll explain what they actually do. So this was the interface. Let's move into the implementation. We're just going to start with a stub. So of course, import that header we just wrote, and then let's just describe what the get method does. Now that's going to return the value for any given property accessed. So at its simplest level, you might do So here's my variable global.objc. Maybe I do global.objc.toString, and then the word toString will come in as a prop name, and we've got to decide what to do with that. But not just toString, maybe they're asking for UI view, and we've got to grab a UI view. So all sorts of things. And yeah, for now we'll just return undefined. And then the other API is get property names, and this defines the list of enumerable keys. So if you call object.keys on this host object, it's going to tell you, it's going to list out everything that we've specified here. So we'll probably want to list out things like NSString to know you can call global.objc.NSString and get a wrapped up NSString on the JavaScript side. But for now, we'll return an empty array. This will look a bit alien as well. A stud vector is, in my head, it's a mutable array, and it's a mutable array of prop names. So we're just going to return that while it's empty. Next up, we are going to go back to that ObjectiveC runtime file, and we're going to expose host object ObjectiveC. So remember our set property call. We don't need that JSI string anymore, but what we are going to do is we're going to instantiate a host object ObjectiveC, and we're going to wrap it in a shared pointer. Finally, we go to app.tsx and we try logging it out. So first up, if you try logging it as is, you'll just get an empty object visually. If you try listing out the keys, you'll get an empty array. And if you try calling toString, you'll see something possibly surprising. I'd expected toString to be implemented, but turns out you don't get that for free. So in the repo for this project, which I'll be providing a link to by the end, we do actually implement toString tag, which gives you toString as a result, but we're not going to go into it in this talk because there's no time. Right, but let's start easy, exposing a known serializable API from ObjectiveC. Here's our target. We have this API declaration, NSString transform. It's an NSString transform Latin to hiragana, and it's of type NSString transform, which is really just an NSString by another name. This is a global variable, is what I want to say. And we want to make it available on the JS side when you access ObjectiveC. I can't pronounce ObjectiveC very easily. ObjectiveC.NSString transform Latin to hiragana. We want it to return the string value of that variable because it is an NS string. It has an inherent string value. We'll like to see what that is. So how do we go about that? Go into host object ObjectiveC. We are going to add a little to the getter. Don't forget to import foundation because we're just about to call something from the foundation library. If the user calls ObjectiveC.NSString transform Latin to hiragana, that name will come through and we can have a case for that. And in such case, we'll return a JSI string based on the UTF string value, which is a C string, for that variable that we pull out of global scope. And this is a really cool thing about ObjectiveC++. You can seamlessly do ObjectiveC stuff in the middle of a C++ context. It's crazy stuff. And to illustrate, we will update the enumerable keys, and it's as simple as saying there's a new enumerable key called NSString transform Latin to hiragana. Let's look at the result. On the TypeScript side, we'll try accessing it, and you'll see what it logs out. That first line, when we're logging out ObjectiveC as is, you'll notice that it gives, for each key, I think potentially each enumerable key that we specified on the object, it does a get on that. So do be careful if you've got any sort of expensive things to call get on, because the standard logging will show it off. And you'll see the value for NSString transform Latin to hiragana is close bracket KCF string transform Latin hiragana. And if you object keys, you will see the list of keys. So congratulations, you just proxied a native API. Now there's a lot more you can do from here. Let's go the whole way exposing arbitrary Objective-C APIs, even non-serializable ones. Now we could sort of do an individual, we could just focus on NSString and call it a day, but that's a bit boring. So I kind of thought, with the time remaining, how about we go the whole hog? No matter what class they ask for, we'll have a solution. In fact, we'll have a way to wrap it. And once they've got a class, how about we let them make instances of that class and call methods on it? Maybe we've got enough time, but we'll see how rushed this gets. So, how do we approach this? We'll approach it by improving our host Objective-C class we already made. It will handle any value in Objective-C runtime. Now, for that, the constructor will now need to take a pointer to a native object, allowing us to wrap any native data type, and a isGlobal param just for the special case of the global object. That get method we implemented before will now proxy through to the underlying native object, and the get property names will now list all the available properties. We'll skip set as there's not much time. So, a few changes here. Point number one, we've introduced this new enum, which expresses the various different types of native reference we support. We have other, just a catch-all. Yeah, we don't really do anything special for this, but we have classes, class instances, and then the global. And you'll see that now means our constructor has a native ref as a param. We're using void star, kind of catch-all, and then bool as a param to say, is it the global or not? We then got a member variable, that's native ref, and then we've got a member variable for the type, so that once we've figured out the type at construction time, we don't have to keep rechecking it during our implementation. And then no changes to the methods implemented. Part two, we will just outline what the implementation is going to be like. So in our constructor, we are going to determine the type of native ref and initialize the M type. Point number two, if the M type turns out to be global, we're going to look up all classes, protocols, or variables matching that name. Otherwise, if the M type turns out to be class or class instance, we will look up methods or properties. And if we get a match for none of those, we'll just return undefined. For get property names, we will also return the name for every case that we handle in the get method above. You'll recall that we instantiated an instance of host Objective-C when we set it on the Objective-C global. We just need to update the constructor, so it now takes null. Well, you could really pass anything in here for the case of global. We just need to pass something in, and we've said true because yes, this is the one time where we're making one of these, and it is for global. Now here is how we're going to implement the constructor. So first off, if the person on the outside told us it's for global, then easy peasy. We say the M type is global. And for the next things, we're going to need to import some Objective-C runtime helper functions. So we'll do a try-catch, and the interesting thing about try-catch with this @ symbol in front of it is it handles both Objective-C and C++ exceptions as long as it's a 64-bit app. Don't ask me why, but that's what Apple said. First we're going to find out, is it an NS object of some sort? And the way we do that is we try firing an is kind of class message at it, which will throw an error if it's not an NS object in the first place, in which case we fall through and we set the type to other. But if it does respond, we will do a bit more meta-programming. We'll say, okay, get me the class of that thing, and if that class turns out to be an Objective-C meta class, then we know the only way that could have happened is if that thing we were holding was a class rather than a class instance. Because if you ask for the class of a class instance, it will give you the class. But if you ask for the class of a class, it will give you the meta class. You'll notice also we're doing that cast to bridge NS object. So the native ref came in as a void pointer. We have to say, so if we're going to call an NS object method on it, we need to say, well, you're an NS object, is the going assumption. And because we're doing this in a, I think the reason was we're in a C++ context, we need to either change the pointer ownership, or anyway, what I've gone with here is I say bridge, please, and it means no change in ownership of the pointer, and I don't know, it's just what the compiler suggested as the auto fix, and I've rolled with that. Next up, now we're inside the get method, and we're going to implement class and protocol getters. So this will be for the case where they do ObjectiveC.NSString. So we're a global right now. So point number 1, if it turns out yes, we're global, first thing we're going to do is use the ObjectiveC runtime helper NS class from string, whereby we pass in a string saying, here's the name of our class, for example, UIView. And if it does return a class, then we know, bingo, our work here is done. We can wrap it up in a host object, ObjectiveC, and return that. If we get no hit for that, then maybe it's a protocol. So we'll try NS protocol from the string and wrap that up and return that. If not, we'll continue on to the next slide. I've just got no space to show all the lines for that block in this one slide. If it's neither a class or a protocol, we'll see if maybe it's a global variable. And for global variables, we've got to dip into the dynamic linker. So we import that up there. We use dlsim. Really, don't think about this too much. We use dlsim, look up the name of the symbol, and if we get a hit, we will wrap it up, dereference a pointer as necessary, and create a host object from it. If not, we return undefined. Now, suppose we're not the global, we're of other type. We're just going to return undefined for the getter. And if we're a class instance or a class, we will create an NS selector using that string name, and we'll call invoke method. Now, I'm not going to tell you how to implement that in this presentation. I'd say check out the repo. It's quite a long method, and uses a lot of Objective-C metaprogramming. Now, if we got no hit for that selector, if there's no method by that name, I will just continue the block on the next slide. And maybe it's not a method, but it's a property. So let's handle that. Classes and class instances have subtly different ways to get the properties. You either do it using, either way you need the class itself, and then you call class get property. Pass in the name. If you get a hit for that, we go a bit further and we grab the value for that property, and we marshal it into a JSI object. And that's using one of the helper methods from JSI utils, convert Objective-C object to JSI value. And if none of those things worked, our default case is to return undefined. Get property names, I'll just breeze over this. Bunch of Objective-C metaprogramming. We will copy the you know what, I don't have time to go over this, but there you go, you can look at that later. Now there are some other things I don't really have time to go into, like as mentioned, setters and the invoke method implementation, and for both of these I say just check out the shirakaba/rn Objective-C repo. Finally, we'll get into app.tsx and we will invoke it. We will try to use all the features at once. So we will ask for an NSString class, we'll allocate an instance of it, and with that instance we will call a instance method, which is another initializer. We say, here's a JavaScript string saying shirakaba, and we want to call a method on the NS string we get back from that, which is to transform that Japanese phrase into Latin. That's a transliteration. It doesn't actually translate. And when you finally log that out, you'll see the result is it's translated shirakaba into, shirakaba, but Roman letters. And after all that, congratulations, you can now arbitrarily access the ObjectiveC runtime from JS. It handled all that marshalling and holding onto objects, and it was just great. And they all lived happily ever after. Or did they? So here's a confession. I have had a lot of problems implementing this. It's a bit inconsistent. It's not totally working. I get a lot of cases of bad memory accesses, and I suspect it's something to do with strong and weak refs. I think I need a strong ref, and I'm just doing things wrong, and I keep ending up pointed at bad memory. So it's only on a good run when all this works, but it works in theory. So this is sort of something I'd really love some code review on by someone who's much better at C++. The whole reason I'm creating this is because I am a JavaScript guy, enemy of native code. And so obviously I have some weak spots on the C++ side. So that was one of my worries, memory management. Are we losing our native refs? Are we leaking memory? Is it secure? Because as you just saw, we got into some memory we weren't allowed to access. Further work's needed for marshalling C values, because right now we only handle things that extend NSObject, and TypeScript typings. We've just got any type at the moment. Debugging is hard as everything's dynamic. And there's always the unanswerable question, will Apple reject apps using this library? I don't really have an answer for that, but I've got some future ideas. Maybe someone can come along and say, oh, I know exactly what's going wrong with the memory accesses. Here's some help. We could change from dynamic access to static access. So use, for example, NativeScript or Xamarin's approach to finding out the names of all the classes that exist in runtime, and not just classes, methods and everything. And we can make a dedicated file describing here is NS string and everything you can want to do with it, rather than relying on things like the dynamic linker and ObjectiveC runtime helpers. I'd like this to be used as an approach for smaller scale libraries, as I said, maybe just tackle NS string on its own. It would be cool to have an Android equivalent of this. And other options are, if I can't get the memory right in JSI, maybe just delegate to NativeScript. We could use JSI to call NativeScript from React Native, or even better, swap React Native JSC or V8 for NativeScript JSC or V8 and call it directly. So, in conclusion, JSI and ObjectiveC C++, not so scary for simple tasks. JSI is suitable for arbitrary native API access if we get it right. I hope you learned a bit more about C++, ObjectiveC metaprogramming, and building JSI modules in general. So thank you very much for attending. My name's Jamie Birch, and that's all from me.